the next concept is types of transformers. There are three types of transformers: core type of transformer, and shell type of transformer, and berry type of transformer. But in an examination point of view, these two are very important. In a core type of transformer, it has two limbs. It has two limbs. But in a shell type of transformer, it has three limbs. The cross-sectional area of both the limbs will be same. The cross-sectional area of both the limbs are same. But here, the cross-sectional area of the central limb is double that of outer limbs. And on the limb we are wound the winding. So here core is surrounded by the windings. Core is surrounded by the windings. But coming to shell type of transformer, windings are inside. That means windings are surrounded by the core. So if you observe, the windings will be inside. So this is the primary winding and this one is secondary winding. Primary winding and secondary winding. Both the windings are wounded on the central limb. And if you observe the flux which is produced, it has only single path. But in this, the flux is developed in the core is divided into two parallel paths in the core, that is 5/2 in the 5/2. The flux which is developed in the central limb is divided into two parallel paths in the outer limbs. This is the flux direction. So then we can say that it is a series magnetic circuit. It is called as a series magnetic circuit. So it is a shunt magnetic circuit. That means parallel magnetic circuit. And so generally the core is surrounded by the windings. Core is inside. And also it has a two limbs. Less insulation is required. Here three limbs are there. So more insulation is required. And here amount of copper required is more because the windings are outside. Copper required is more. You can observe that the copper winding is placed on the central limb. The copper required is less. So finally, the core type of transformer is used in high voltage and low current applications. And this can be used for low voltage and high current applications. So some part of the flux is passes through the air, and here also some part of the flux is passes through the air. The flux which links either primary winding or the secondary winding but not both the windings. whatever the flux which is developed here, which is links only primary, here also the flux will be developed, it is links only secondary but not both. That flux is called the leakage flux. But coming to here, so the flux passes through air here, here also the flux will be passes through air. So I am using a different color. So this is the flux which is produced here. Then the flux which is produced, it is common for both the winding, then we can say that the leakage flux is reduced. Last point, leakage flux is more. Leakage flux is more, but here leakage flux is less. The leakage flux is less. So these are the differences between core type and shell type of transformer. So in an examination, if we may ask the differentiate between a core type of and shell type of transformer, you should write all these points along with these two diagrams. And one more point is there. This is concentric winding is used, and here sandwich winding is used. The most important concept, the next one, is EMF equation of a single phase transformer. The EMF equation of a single phase transformers. Single phase transformer. This is a very important, and this is repeated so many times in a university's examinations, and definitely you will get 8 marks from EMF equation and 7 marks is a problem on EMF equation. So what is a transformer principle? So I am taking a core type of transformer. In a core type of transformer, it has 2 limbs. So I am wound the winding like this. So primary winding, this one is secondary winding. I am applying a supply voltage here. Then the alternating current is flowing through transformer primary winding, which will produce an alternating flux. This flux link with the primary winding and secondary winding, an EMF induced in a primary as well as the secondary. The primary winding has N1 number of turns and this one is N2 number of turns. So this is a flux in the transformer core, phi m versus omega t. The total time period of this waveform is t, and both time period and frequency both are having inverse relationship. In this half of the time period, the half of the time period is t by 2. What is meant by time period? Time required to complete one cycle is called the time period, and the quarter half is this length, t divided by 4. T divided by 4. The value is phi maximum. With this alternating flux, according to Faraday's law, an EMF is induced according to Faraday's law. So this minus sign is according to Lenz's law. So E is equal to minus n into d phi by dt. Lenz's law is effect will always opposes the cause. Effect will always opposes the cause. We will discuss later. Then the average value of EMF induced in a conductor E is equal to N into d phi by dt. So the average value of EMF induced per a conductor E is equal to N into d phi by dt. The average value of induced EMF in a conductor E is equal to N d phi by dt. See here, when the flux is changes from 0 to phi maximum, as d phi is equal to phi max minus 0. So the time is also increased to 0 to t by 4. This portion is t by 4. So dt is equal to t by 4 minus 0. Substitute here in an EMF equation of a single phase transformer. E is equal to N into d phi is phi minus 0 divided by dt is 5 t by 4, and this will be 4 into phi m into N divided by t. So the frequency value is, that is inverse of time period. So 4 into phi m into the 1 by t value is f into N. This EMF is called the average value of induced EMF in a conductor. But generally AC is measured in RMS value. We have a relationship between the RMS value and the average value, that is called the form factor. So form factor for alternating quantity is 1.11 RMS value by average value, that is E RMS divided by E average. Then E RMS is equal to 1.11 into E average, that should be equal to 1.11 into 4 into phi m into f into N. So finally I got it as 4.44 into phi m into f into N. If it is a N1 number of turns, E1 is the primary induced EMF, 4.44 into phi m into f into N1. If it is a N2 number of turns, E2 is equal to 4.44 into phi m into f into N2. Then from this equation, E1 by N1 is equal to 4.44 into phi m into f, that should be equal to E2 divided by N2. E1 by N1 is equal to E2 by N2. From this equation we can write it as E2 by E1 is equal to N2 by N1, that is K, where K is called the transformation ratio. What is K is called? The transformation ratio. And turns ratio is also there, that is represented with a small n, is equal to N1 divided by N2. Okay, this is very important. The EMF per turn on both sides of the transformer is same. The E1 by N1 is equal to E2 by N2. Whenever sinusoidal voltage is given to transformer primary winding, an alternating current is flowing through transformer primary winding, which will produce an alternating flux. When the flux is changed from 0 to phi maximum, the d phi value is phi maximum. The time is changed from 0 to t by 4, and dt is also t by 4. According to Faraday's law of electromagnetic induction, EMF induced in a conductor is equal to minus n into d phi by dt. Substitute the values. 1 by t is equal to frequency, and generally AC is measured in RMS value instead of measuring average value. There is a relationship between the RMS value and the average value, that is form factor. The value of form factor for sinusoidal is 1.11, and then you can find the EMF equation. E1 is equal to 4.44 into 5m into F into N1, and E2 is equal to 4.44 into 5m into F into N2, and E1 by N1 is equal to E2 by N2, and finally this is very important, K is called the transformation ratio, and it should be equal to N2 divided by N1, it should be equal to E2 divided by E1, and turns ratio is N1 by N2, transformation ratio is N2 by N1. Thank you.